What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. What's up everybody, my name is Eric. Welcome to my channel. Today we're going to be talking about Malonic Ester synthesis, and I got a nice reaction ready for us, so let's go ahead and dive in. Now the first thing I see here is we're reacting this with an NaOEt. Now our NaOEt looks just like this. Now notice something about this group is the exact same group that we have here and here. Notice our molecule is symmetrical. Now if this NaOEt happened to have been NaOMe, so if it was a NaO with just the CH3, then if we reacted this with this group over here, we would actually get a trans esterification, and this group would want to attack the carbonyl carbon, okay? But because we have the exact same group here as we do here, then we can go ahead and take this charge and we can grab an alpha hydrogen. Now notice that this hydrogen is highly acidic. It's between two carbonyl groups. So let's go ahead and draw what we would get. So there's our negative charge. We could draw a resonance structure for this. So let's go ahead and do that to be thorough. Here's our resonance structure. Just like that. So we could use either of these two molecules for our next step. Now, what do you guys think our next step is going to be? Well, I see that we have a nucleophile, and in our step number 2, we have our electrophile. So the electron density from this oxygen is going to come down, and this pi bond can go and grab the carbon that's directly attached to our bromide. So then our Br is a good leaving group, so we can go ahead and lose our bromide, and let's see what we get. Reformation of our carbonyl. Now coming off of this carbon, we now have a new group. We have 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. So let's go ahead and put a Br right here. 1, 2, 3, 4 carbons. So right here we have 1, 2, 3, and 4 carbons with a Br. Okay? So let's go ahead and fix that. We're going to need 4 carbons total. So 1, 2, 3, and 4, and then the Br. Great. Now what's our next step? Well, I see that we have another NaOEt. So here's our NaOEt. What do you think it's going to do? It's going to do the same thing just like on our previous step. So we can go ahead and grab an alpha hydrogen. That alpha hydrogen is available. There was one left. So now we have negative charge on this carbon. Now if I were reacting this with another carbon, another reagent, then perhaps this would go and attack that, but we can actually do an intramolecular formation and get a ring here. So this negative charge can come after this and kick this Br out. This is going to form a 1, 2, 3, 4, 5-membered ring. Let's go ahead and see what we get. And just like that, we have 1, 2, 3, 4, and 5. Now, we can go ahead and check these guys off. We're on this last step here. This last step is going to be a little bit longer. So I see an HCl. Let's go ahead and see what we get. We know that in order for our water to react, our water is a poor nucleophile, and we need this oxygen, this carbonyl group, to be charged up. So we got to charge this group up before our water can attack at this carbon. right, so now we also have some Cl minus floating around, and at this time we have our H2O. Our H2O can take a lone pair and come attack this carbon, push this group up. So now we get here's our OH. Here is our new water group. And coming off this carbon, we still have our OCH2CH3. Now we can make this OCH2CH3 a good leaving group, and we can fix this oxygen and make it happy again, because right now it only has 5 valence electrons and it wants to have 6. So let's go ahead and draw our next step. Here we have O, so our carbon structure, our OH, another OH with a new lone pair, and our better leaving group. Now that this is a better leaving group, I can take one of these lone pairs and bring it down to kick this group out. So we lose HOCH2 CH3. So let's go ahead and write that. Just like that. And then we also get looks like we're forming a carboxylic acid. This Cl minus that we had in a previous step can come reprotonate the Cl to become Cl minus. We can deprotonate our carbonyl. All right, looking pretty good, right? So now we have our carboxylic acid. I'm going to go ahead and write this a different way so you guys can see what happens when we react with this heat, okay? So this is the same structure I'm going to draw. So I'll go ahead and just draw another arrow. I'm just going to draw it a little bit differently so we can see what the heat is going to do. So here's the carbon right there. Attached to that carbon, I have the carbonyl, and I have my OH. Okay. Now what's going to happen is this pi bond is going to break, and it's going to go grab a hydrogen. This pi bond breaks, and this group right here is going to form a single bonded OH. Now when that happens, the bond between this O and this H is going to break, and it's going to go onto this line here. So we're going to form a pi bond right here. We can see that right here we're forming something very special. This is going to form a carbon double bonded to an O, double bonded to another O. This is CO2. Now, in order to maintain the octet, we have to break this bond, and it's going to go right here. Okay, it's going to form a CC double bond. So let's see what we get. This side hasn't changed. This side, this carbonyl is no longer a carbonyl. Now we have single bonded OH. Coming off of here, we still have our ring. And now we have a double bond right here, okay? So notice how coming off this carbon, we have R group number 1, R group number 2, and this bond here. So when this bond breaks, we're left with 4 bonds at this carbon. So this carbon is just fine, and this left as CO2, okay? Now, we have some HCl floating around from a previous step. This step we made HCl. So what can happen is this double bond, this OH here can come down to form a double bond, and this can go grab an HCl, just like that, okay? So let's go ahead and see what we get. So now we have double bonded O with positive charge on that. This came down. We have our carbon structure here and a new hydrogen. We also have some Cl minus floating around. So we can solve this problem just like that. C double bond O. Here's the rest of our molecule. Looking pretty good. Now it looks like we're almost done, but we got to finish this up. This over here, anytime we have an ester group and we're reacting with water, we can get a carboxylic acid. So this HCl is right next door, right? We just formed more HCl. So here's some HCl that we just formed right here, HCl. This can grab a hydrogen, kick this bond off. Now let's go ahead and see what we get. Here is our charged up carbonyl. Now we can react with water once more. Come right in here. Here's our OH. Here's our OH, H, and our carbon ring. We can make this a better leaving group. Kick that on there. Let's see what we get. So now we have a better leaving group. OH plus, OH, OH, and our carbon ring. This OH can come down, and we can kick out our leaving group. So we're left with HO and this, plus this came down to form a carbonyl, positive charge there. We still have our carbon ring, that hasn't changed. And on the other side now, we have a carboxylic acid. All right, and then in this step, we also formed some Cl minus. Cl minus. So the Cl minus can come and grab the H and finish this guy up. So what's our final product? We have an OH, the carbonyl. Here's our carboxylic acid with our 5-membered ring. We had some CO2. We also had some methanol. Okay? So this is going to be our final product. Thanks for tuning in, guys. See you next time.